Hello, my name is Bence Bereznay. I would like to introduce you the nanotechnology during my presentation. Go to shopping. I would like to buy 7,428,501 piece of gold atomic kernel. What does it mean? It is a 1 centimeter long and 1 atomic thick gold necklace. One atomic kernel is 0.40 nanometer big or rather small. It was that we won't discuss about big things, but how small is that very small? According to the scientist, it is 10 on the minus 9 meter. It is approximately the 50,000th part of human hair. Now let's see the past, present and the future. Let's start with the size and dimensions. Here is the 1 meter, which is an SI dimension. In this graph from left to right, the dimensions are decreasing. The splittings are by 1000. You can see that the hair is less than a millimeter. Then the next one is the bacteria. The Pentium 4 transistor is even smaller than a micron. The size of a virus is between a Pentium 4 transistor and an atom. As you can discover, the atom can be measured by nanometer dimension. Let's go back to the past. If 60 years ago we had asked what is the nanotechnology, then everybody would have considered us an UFO. The nanotechnology has a short history since O. Freeman discovered it in 1929 December. It has advanced a lot. According to a forecast in 2003, the number of nanotechnology investments could gain by 200 or 300%. The forecast said in 2015 the nanotechnology would have 800,000 employees and 120,000 researchers. Moreover, it would have $1,000 billion to invest. In olden times, we used carving to reduce things. Carving makes a lot of chippings. It requires so much energy. It makes significant material loss, so it also polluted our environment. Nowadays, preparing. It can be applied in the medical area, in IT area, and to store energy. Furthermore, it can help us in materials sciences, in environment protection and in food producing. Of course, we can apply nanotechnology in nanoproducing and its security techniques. Near future, from small things to big, from atoms to molecules. New materials, for instance graphene, are created from molecules. Less chipping, so less environment damage. Economically, effectively. First example. Let's see first the most interesting, Harry Potter's invisible cloak. It was created from nanopiles. Consequently, the light flows around the object. As a matter of fact, it doesn't work on all frequency. Second example, computers versus cooling. How did we get from building cooling to little fingernail cooling? Electromechanical computer, it appeared in 1938. Computers with electron tubes, 800 kilowatt, they were used between 1943 and 54. Computers with transistors around 80 kilowatt, the technology was used between 1954 and 64. Machines with integral circuits around 5 or 8 kilowatt, it was used between 1964 and 71. Computers with microprocessors between 200 and 800 watt operated between 1971 and 91. Computers with microchip between 2 and 80 watt in computers nowadays. Third example, mobile phones. Phones today contain 2 or 4 or 6 or even 8 processor cores. Processors require less and less space, so the cooling has to improve. The transistors located above each other in small places to formate the heat conduction between the layers is a very hard thing to do without increasing the size. On the picture we can see a mobile phone from the future. The parts of it can be changed by individual standpoints. Solution. Cooling can't be forgotten. Cooling on the surface, cooling the middle layer. This is not bad, but not enough useful. Make an integrated heat transporter layer. That is nano because the sizes. Improve the block conduction ability by space filler corpuscle. Reduce the bond night thickness. Optimize the nanostructure of the thermic and electric contracts. Thank you for your attention.